Hello everyone. So let's continue our analysis of AC networks. And in the previous video, we looked at this problem where we tried to solve a two loop network and find the current in the 5 ohm resistance using superposition theorem. Now, in this video, I'd like to use Thevenin's theorem and solve it. So just quick review, superposition theorem. What we did was considering one source at a time. So this source is short circuited and this source is considered and found the current here. Then I considered the other source and then again found the current. And then adding these two currents together, I got the final answer as 2.3687 amperes and at the angle of minus 74.824 degrees. That was with superposition theorem. Now the question is, if I use Thevenin's theorem or any other theorem, will I get the same answer or a different answer? So let's check that. One small thing I would like to mention here. In the previous video, I did not mention the direction. So this is assumed to be plus and this is a minus direction for this voltage source. So with that, we'll continue. So now this is part 5. So I come to page 5. I just copied the same question here. So as I was telling, this assume it to be a plus and minus sign for this voltage source. Now the objective is to find the current in the 5 ohms resistance, this time using the Thevenin's theorem. So let's call this 5. So now using Thevenin's theorem. So how do you use Thevenin's theorem? So first step is to find the Thevenin's impedance. So first step is find Thevenin's impedance. So what is the procedure of finding Thevenin's impedance? What we do is we remove the load resistance. So between these two terminals is my 5 ohms. You remove that, short circuit all the voltage sources, open circuit all the current sources and find out the equivalent impedance as observed from these two terminals. So let me draw the circuit here. So I this is short circuited and then this is J3 and this is minus J4. Then here I have a 3 ohms resistance and then this voltage source is short circuited and here I have a J6 ohms and the load resistance is removed and then whatever is the equivalent impedance as viewed between these two terminals looking into the network, this is what is the equivalent impedance. So what is my Thevenin's impedance in this case? I notice that these two are in series, so J3, J4 are in series. That particular branch is in parallel with 3 ohms resistance and that entire parallel combination is in series with the 6 ohms resistance. So I get J3, J4 are in series, so plus J3 minus J4. So that will be minus J. This is in parallel with 3 ohms resistance and that combination is in series with the 6 ohms resistance. So I just add like this. So this is my Thevenin's impedance. So how do you find the parallel combination? So it is nothing but Z1 Z2 by Z1 plus Z2. That's the thing. So minus 3J divided by 3 minus J. So this is the equivalent impedance of the parallel combination plus J6 is the series branch that we are adding. So this is a total impedance that is viewed from the outside. So let's do this calculation. I'm switching over to my MATLAB window and then here I'll do that calculation. Okay, so ZTH, Thevenin's impedance, is nothing but minus 3I divided by 3 minus I. So basically this is a parallel combination plus 6I is my total Thevenin's impedance. So I'm getting 0.3 plus 5.1 I. So 0.3 plus J 5.1 ohms. So this is my Thevenin's impedance. I can convert it to polar form, but I'll leave it here. That is the first step. So what is the second step? So find the Thevenin's voltage. So Thevenin's voltage is the voltage that would appear across these two terminals with all the voltage sources, everything acting. So if I had connected a voltmeter between these two, I remove the load resistance, connect a voltmeter, how much voltage will I be able to measure? So let's draw the circuit once again for that. So I have one voltage source here, and then this is J3, and this is a capacitance J4. Then I have a 3 ohms resistance here, and then I have another voltage source here. This is my terminal, and then here I have a J6. Now my objective is, if I connect a voltmeter at these terminals, so this is the voltmeter I am connecting at these terminals. How much volt? So let me just write like this. Voltmeter. So how much is the voltage? So that is nothing but VTH, Thevenin's voltage. So one thing you should know, let me write the values also here. So I think these values are 40 volts 0 degrees, and this one is 30 volts 45 degrees. Very important, the polarity. So this is plus minus, this is plus minus. Let's be consistent as we saw in the earlier original question. That is 40 at 0 degrees plus minus, 30 and plus minus like this. Okay, so coming down, now you notice that since this branch is open circuited, so I'm a little uncomfortable. Let me just delete this whole thing. So I'm interested in finding what is the voltage here. So this is nothing but VTH. So this is my positive terminal, this is my negative terminal. That's what is my convention I'm finding out. So you notice that this current will be 0 in this, because this side is open. Similarly, this side open, the current in this will be 0, the current will be in this 0. The only current will flow is in this part of the circuit. So let's call this as I1. So what is I1? I1 is nothing but V divided by total impedance that is seen in this branch. It's a simple circuit. So 40 0 degrees divided by J3, 3 and J4. So J3 plus 3 minus J4. So this is just the total series impedance, and this is the total voltage. So I'll get the current. And once I get this current, I multiply with 3 ohms, then that gives me the voltage drop across this particular 3 ohms resistance. What is the voltage drop across this? So the voltage drop across this is anyway 0 volts, because the current is 0. Okay, let's do this current now. What is I1? So I come back here. I1 is equal to 40 divided by, I have 3I plus 3 minus 4I. So I'm getting 12 plus 4I is the current. So the current here is 12 plus J4 amperes. So once I know this current, I'll just find out the voltage drop. So voltage drop in 3 ohms resistance is nothing but 3 into I1. So 3 I1. So that is nothing but, so you can see it here, 3 into I1. So let's call it as VD3, voltage drop on 3 ohms resistance, 36 plus J12. So this many volts are dropping in this. Now I want to find out the Thevenin's voltage. So voltage of this point with reference to this point. So what you have to do, if I consider this as A and B, if I want to find out voltage of A with reference to B, you start at B and then track your path and go up to voltage A. So from B to this point, let's say call this point is C, the voltage drop is 0. But from C to here, the voltage will increase. So why the voltage will increase? Because the current flows from high voltage to low voltage. So because that is the direction of the current. So the current is going like this. So this is at the higher voltage compared to this voltage. So from here, from point C, if I go to say point D, my voltage will increase. And then from point D to point A, when I go, my voltage will decrease. So therefore, my Thevenin's voltage will be 0 plus voltage drop here minus this voltage V2. So VTH is nothing but 0, and from C to D is plus 36 plus J12. This is one voltage, and then from D to A, from positive terminal I'm going to negative terminal. So my voltage is falling down. So therefore I have to give minus sign 30 angle 45 degrees. So this is my total Thevenin's voltage. Now the problem is here, this is in rectangular form and this is in polar form, and I want to subtract. So I have to convert this also into polar form, that is rectangular form, and then I'll be able to convert that. So how do you represent that? Again, let me just refresh your memory. We have done this in the previous videos. 30 45 I can represent it as 30 e to the power of j 45 degrees. So if I mention this in my MATLAB environment, then it will come out as a rectangular number. So e to the power of, this is just a product. So if I do this, I'll get the Thevenin's voltage. So let's do that. So I already have VD3. So VD3 is the voltage drop minus, now V2 is 30 and EXP 45 degrees. But then this degrees I have to convert into radians. So that's why I divide by 180 degrees and multiply by pi radians. Then it becomes a angle in radians. And then this I will be subtracting. So this is the voltage I am getting. So I'm getting a minus sign, but nothing to worry. This is correct. So let's assign this to VTH. VTH is this voltage. Now once I have this, I'll go back and then I will like to now calculate. Just a minute. I'm just getting a doubt. VD3, let me only just calculate this part, 38 45 degrees. Oh, I'm sorry, I forgot to add I in this. So my doubt was clear, my doubt was correct. So let me just add I in this. So I have to multiply I, so I into 45. So what did I write here? Yeah, I have written J here. So this J I have to multiply. So now I get the Thevenin's voltage, that is 14.7 and then 9.21. So 14.78 minus J 9.21. That's it. So now my two steps are over. This is in Thevenin's voltage and voltage. So I just the next step is to connect or create your Thevenin's circuit, something like this, and then finally is your load impedance or load resistance. This is 5 ohms. So how do you find the current in the 5 ohms? So current in the 5 ohms is nothing but, let's denote it as I5. So I5 is nothing but VTH divided by ZTH plus 5. That's it. So if I do this calculation, I'll get the current in the 5 ohms resistance. So this is my step 3, finding the current. So let's do that. VTH divided by ZTH plus 5. So I'm getting current is 0.058 minus J 2.29 something. Now this I want to convert into polar form. So I5 is this. So absolute value of I5, I'll just get the result as a matrix, and then angle of I5. Then this is multiplied by 180 divided by pi, because the angle will be provided in radians. So I multiply with this to get the angle in degrees. So I'm getting like this, 2.3687. So finally this is 2.3687 at an angle of minus 75.8 degrees. So this is my current in this one using, so final current using Thevenin's theorem. So let's verify whether the same 2.3687 we got it from the other one. So I'll go to the other page. So this was the previous video in which I solved using superposition theorem, and this was my final current, 2.3687 and 75.824 degrees. and then yeah, so exactly we are getting the exact value of the current. So that means our answer is correct. We verified it with two different theorems, so we are able to get it. So verified and correct. So it's always very satisfying when you solve a circuit and then check your answer and then answers are correct. So it gives a good feeling. We also have one more theorem to go. So how do you do it with mesh analysis? Again, do we get the same answer or different answer? So we'll do that in the next video. Thank you.